Today we're going to be learning about the distributive property. We should be on page 288. Page 288. Page 288. In example 1, we're just writing equivalent expressions, okay? So we're starting with, we'll do a couple of these. We're starting with an expression, 3 times 2 plus 3. Now, let me just begin this by saying, okay, this lesson is not a test of your mental math skills, okay? I know that you could add 2 plus 3 in your head and get 5, and the 3 plus 5 is 15. That's not what I'm concerned about. I'm concerned with teaching you the distributive property using simple terms to start. Now, in the next chapters, we're going to be using different variables, exponents, all kinds of things with the distributive property, so it's important that you understand it. So, if I wanted to write an equivalent expression for this expression, I would take the number on the outside of the parentheses and multiply it by every term inside the parentheses. And here's how I would write it. 3 times 2 plus 3 times 3. Okay? I've just written an equivalent expression. What did I do? I took the number on the outside and multiplied it by every term within the parentheses. Okay? Now, in order to check my answer, which you'll be asked to do on your homework tonight, I'm going to solve both sides of this, and I'm going to solve them differently. On the left side, I'm going to combine the terms within parentheses and multiply. On the right side, I'm going to multiply, and then I'm going to add together. But either way, I'm still going to come up with the same answer on both sides, so I would know that my answer checks out. Your answers must be the same for each expression in order for you to have used the distributive property correctly. Okay? So on your homework, you'll be asked to write an equivalent expression and then check your answer. So let's do one more. What if you had, one more for example 1. What if you had, let's say 4, no, let's do 5. 5 times 2 minus 6. Okay, 5 times 2 minus 6. Now I need to write an equivalent expression for this. So, same thing. I take the number on the outside and multiply it by every term within the parentheses. So my equivalent expression that I must write on my paper is 5 times 2. But what's going to be different about the second term? Zach? There's a negative. But is the 5 negative or the 6? The 6 is. So I still have an addition sign between my two terms because 5 is positive. Plus 5 times what? Times negative 6. Okay? And now that I've written my equivalent expression, I'm going to solve both of them to check to make sure my answer is correct. 5 times, what's 2 minus 6? Negative 4. All right, so those positive and negative integer rules still apply. Same sign, add and keep, different sign, subtract and take. 5 times negative 4 equals 10 minus 30, or plus negative 30, either way. All right, and then when I solve, 5 times negative 4 is negative 20, and what's 10 minus 30? What's 10 minus 30? Negative 20, very good. Because 30 is the larger number and it's negative, so they check out. Okay? All right, so now any questions on example 1? Okay. Moving on to example 2. More of writing equivalent expressions. Okay, we're going to do 3 examples. So tonight on your video, you're going to have plenty of examples to look at. Letter A, we have negative 4 times 5 plus 8. Does anybody want to take a crack at what the equivalent expression would be? What would the equivalent expression be? Hazen?
It would be negative 4 times 5 plus negative 4 times
Okay, that's perfectly fine for you to write it that way. Plus negative 4 times 8. Now, technically, you could have just said minus 4 times 8 because then that would still mean that 4 is negative, but that's perfectly fine. So now we have our equivalent expression, and so we have, now we need to solve both sides. Negative 4 times 13 equals negative 20, plus negative 32, or just minus 32. And then we end up with negative 52 equals negative 52. Same sign, add and keep. And it checks out. All right, any questions on this? Now's the time to ask questions. All right, I've explained it. Now, what don't you understand? All right, so now let's do another one. What if you had 4 times 50 minus 3? What do you think the equivalent expression would be? Who thinks they know? Equivalent expression. What's the equivalent expression? Not everybody at once. Chris?
4 times 50.
Mm-hmm.
Plus 4 times negative 3.
Perfect. Okay. So now that we have our equivalent expression, we're going to solve both sides. And we have 188 equals 188. And it checks out. All right, so let's do another example. Now, what if we were to go backwards almost in a sense? What if we were to have 7 times 9 plus 7 times 5? We still need to write an equivalent expression, okay? So here we need to find the common number between the two terms. What is the common number between these two terms that you see?
7.
It's 7. So 7 would go outside the parentheses, and what would be left inside the parentheses? Sebastian? 9 plus 5. And so now we have our equivalent expression, okay? So since we started with it already broken down, we needed to find the common number and then write and then multiply it by whatever was left in the original expression. So now that I have my equivalent, I'm going to solve both sides. 9 times 7 is 63. 7 times 5 is 35. And then 7 times 14. So 63 plus 35 is 98. And 7 times 14 is 98. So they check out. All right. Any questions on that? Kind of working it backwards, working it the other way. All right, let's do one with fractions by popular demand. All right, so what if I had one with a fraction? What if I had 3 times 2/3 plus 4 times, and I probably need a little bit more room, 3 times 2/3 plus 4 times 1/3. I'm sorry, not 4. 3 times 1/3. How would I write an equivalent expression for this? How would I write an equivalent expression? What's my common term?
3.
My common term is 3. My common number is 3. And what would be left inside the parentheses? 2/3 plus 1/3. Okay, so now this is something you need to remember and something that the last class struggled with. If you're multiplying 3 times 2/3, are you changing it to an improper fraction and finding a common denominator and all of that? No, you're actually multiplying 3/1 times 2/3 and 3/1 times 1/3. Okay, and then over here you would have 3 times 3/3. So You could do some cross canceling. 3 and the 3, they cancel, and the 3 and the 3 cancel. So you're just left with 2 plus 1 equals 3 times 1, and 3 equals 3. So they check out. All right, so fractions, I still do them the same way, except now I just need to make sure that I cross-reduce correctly, and then solve. All right, last but not least, example 3. We're looking at a word problem here, all right? Now, again, we're just practicing the distributive property. So, yes, there's an easier way to solve this. That's not exactly what I'm looking for here. I want you to use the distributive property. Now, this is exactly the same as number 21 on your homework, so you may want to go back and watch this part of the video if you're having trouble. It's a lava lamp example. It says that you buy how many lava lamps? Does it say you buy? You buy how many?
8.
8 lava lamps for how much?
$15.95.
$15.95 a piece. Well, that's kind of a complicated number to use, so I could use the distributive property to round it. What's $15.95 round to? $16. But what's the difference between the original and what I rounded it to?
5 cents.
Minus 5 cents. So this is exactly how you would do number 21. All right, now you have 8 times 16 plus 8 times negative 5/100. And 8 times 16 is 128 minus 40 cents. So what's $128 minus 40 cents? 127 and 60 cents. So that's how much it costs. Okay, so we kind of worked backwards a little bit. On your homework problem, you'll need to make sure that you round to the nearest dollar, and then you subtract the difference, and then use the distributive property. And if you understand that, that's everything you need to know for 6.7.